Now let's see how easy it would be to create a new video using the WebAPI in JavaScript. Create usually comes to the post method, and since I'm already in the videos controller, let me just go ahead and replace this post method with a post method that will actually save a video in the database, because it's going to take a video as a parameter. It's going to return an HTTP response message because we want to have some low-level control over what's going to be in that response. I'll show you why in just a second. But if everything about the video is valid and model state is valid, we'll tell the entity framework to add that video to its videos collection. We'll tell the entity framework to save changes, and that should issue an insert statement that saves that video in the database. It will also retrieve the new identity value that was generated for that video and propagate it back and put it into the video. And that's important because of these next 3 lines of code. These next 3 lines of code are here because the HTTP specification actually says if someone does a post to your server and that post operation creates a new resource, what you should return is an HTTP status code of 201. That's the universal status code for, hey, you created something. And that tells the client that something was created. And in addition to using that code instead of just a regular 200, everything was okay, in addition to that, you should also include a location header that tells the client where they can go to get to that newly created resource. So literally a URL that they can use and issue in a GET request to get that resource in the future. And that's exactly what these 3 lines of code are doing. They're building a response that uses an HTTP status code of 201 created, also formatting the video into the response body, and then setting the location by generating a URL using url.link, generating a link that goes to that default API route and telling it what the ID will be. And that literally will come out to be something like location equals /API/videos/5 and tells the client exactly where to go to get to this new video. That's the response that we will return, and that's why we're using HTTP response message here instead of just video, so we can control the status code, control some of the headers that go in that response. If model state wasn't valid for some reason, we'll return a response that says bad request. And if something catastrophic happens inside of here, like save changes throws an exception, that would generate an HTTP status code of 500, which also tells the client that something went very wrong on the server. That should be all the server-side logic we need. What we'll have to add to the UI is some sort of button that I can click on to say, I want to create a new video. So if I look in the index view, let me add a button directly underneath that table of videos called the Create Video button. So obviously, I'll need to wire up a click event on that button. So let me come down to where we wire up all our events on this page. And in addition to wiring up click events on clicking edit and clicking save, we'll also wire up a click event on the Create Video. That we'll just call a function called Create Video that will be very similar to the Edit Video function that we wrote earlier. In fact, we could probably figure out a way to share the code here. But on Create Video, what I'll do is instead of going out and getting a video from the server, just create a new empty video with an empty title, 0 length, 0 ID, and calling Show Video for Edit. That's a function that we've already implemented that pops down that little bit of UI that includes a Submit button. And when the user clicks on that Submit button, it comes back to Save Video. This is a method that we'll have to adjust a little bit because right now it assumes that we always want to update an existing video, but now we might need to add a new video instead of updating an existing video. So let me add some code here that will just check if the video has an ID or not. If the video does have an ID greater than 0 or that's not equal to 0, we'll assume that you want to update an existing video. Otherwise, if video ID is 0, we'll assume you're trying to add a brand new video. And regardless of which operation you perform, when it's finished, we'll need to refresh all the videos in the list and also clear out that edit box. So we're nearly done. We just need to add something to the server object up here that will allow you to call add video. And I'll place that here after update video. Add video is just going to take a video and put it in the data in a post request to the video API URL. Add the semicolon here and add this to the public object that we expose. So add video will go to that function we just wrote called add video. And now I should have everything in place. If I save everything and do a build, and we bring up the browser and refresh it, hopefully the Create Video button will appear. And shortly after that, the videos will appear. This is all good. Let's create a video, a C# video, and just set the length to something like 32. Click Submit, and there we just created a video. Create one more. Let's call this one Entity Framework 180, and click Submit. That seems to work too. So not much code we had to add there. Delete is going to be even easier. Now finally, we'll implement the functionalities that when I click the delete button, I can delete the entity framework. I know that would make a lot of people happy. Obviously, the first thing I need to do is wire up a click event on that delete button. We can do that down here where we wire up the other events, the edit events and the save events. I'll just add another call to the on method saying if anyone clicks on something that has the class delete video, then call this method delete video. That method is a pretty straightforward implementation, very similar to what we've done before. We just need to go out and get the ID of the video where the user clicked delete and tell the video server to delete that video. When it's all done, we'll refresh the videos that are on the screen, but we do not have this method yet on our video server. We need to implement delete video. All of these methods are pretty straightforward and simple. They're all just variations on $.ajax. This one needs to take the ID, formulate the URL to the video API, and issue a request with an HTTP method of delete. That's all we need to do there. And lastly, just add delete video as part of the public API. That should give us everything that we need on the client. We haven't implemented delete on the server yet, so let's flip over to the videos controller, find the delete method, which I believe is down here at the bottom, and replace this implementation with one that takes an ID, again returns an HTTP response message. What we'll do is we'll use the entity framework to find the video that you want to delete. If it's null, return an HTTP status code that says, sorry, 404, we didn't find this. Otherwise, tell the entity framework to remove the video, save changes, that should issue a delete statement, and then assuming everything went okay, we'll return an HTTP status code of 200, include a representation of the video when we do that. If there was some sort of concurrency exception, which we don't have concurrency checking turned on with the entity framework model that we're using, but if there was an exception, we have it set up to create a not found status code. That should be everything we need for delete. Very simple now that we have most of the code written. So let me refresh the page. Our videos will show up, and we will delete the entity framework. We'll delete C# too. So there we have basic CRUD functionality implemented in a WebAPI controller. And we built a page that is using that API to allow a user to create, read, update, and delete videos. Now, if that was all there was to it, you might say, but Scott, I could have done that with a regular MVC controller. Nothing really special about WebAPI that was shown here, but we're not quite finished yet. One of the distinguishing features of the WebAPI when compared to traditional MVC controllers is the fact that WebAPI does content negotiation. We talked about this topic a little earlier in the module, but I wanted to make it a little more concrete by building an application that used the WebAPI and asks for XML data. So the client I'm building is a console mode application. I created this just by going to the solution and saying, add new project, selecting a console mode application. And then another great feature of the WebAPI is the fact that you really don't need any specific toolset or framework to get information from the WebAPI. If you can make an HTTP request, you can get data from a WebAPI. But since we are in .NET and using C#, I'm going to use a WebAPI client that ships with the WebAPI that makes it very easy to make HTTP requests and process HTTP responses. This client, the HTTP client, is a part of the WebAPI. You can install it into any application by saying install package microsoft.aspnet.webapi.client. That'll add all the assemblies that you need. And I do want to point out, even though this HTTP client is part of WebAPI, it doesn't mean that it can only call into something that was built with the Web API. It's really a very generic library and API for making HTTP requests to anything and processing an HTTP response. So once that is installed, I can instantiate an HTTP client. I can say that that client should always add an accept header saying that we are requesting XML. And at that point, I can make a call to the server using get async or post async or put async. They're all async methods. That will send off a request to the server. I'm going to block the thread here and wait for the result. I can only get away with that because I'm in a console mode application and we can just force the user to wait for the result. That's not something you'd want to do if you're building a responsive UI. You'd want to await that result. But we're going to check to see if the result that came back had a status code indicating that the request was okay. If so, we'll take the content in that result and read it as a stream, load that into an X document, which is part of link to XML, create a namespace because the XML elements that are in there by default are created by the data contract serializer, and they'll be inside of a namespace that contains sort of the C# namespace that the particular model object is a part of. So we'll create that namespace, then issue a query looking for all the titles of the videos that are out there and writing them out. And so what does this look like when I run it? Let's just go to debug, start new instance. I can get back the 2 videos that are in the database. I can do that from a console application that has no references or dependencies on that video's web application. It's strictly making HTTP calls, requesting XML, parsing that XML, and displaying the results. In this module, we had a basic introduction to the Web API. We learned that it really embraces HTTP. It allows you to build web services that embrace HTTP. It allows you to build web services that are scalable and highly interoperable. Scalable because you can take advantage of using HTTP GET, which can include caching. Interoperable because you don't depend on any particular specification or framework or tool set when you're building your service. And it's also just as flexible as ASP.NET MVC. It has many of the same extension points. You can plug in your own custom model binders, your own custom formatters, action filters, and all the rest. We also took a quick look at building a client using Web API and the HTTP client class. And one thing that I didn't have time to show you is the ability to self-host a Web API. That's not something you can really do with ASP.NET MVC. It's a bit tied to the ASP.NET runtime. But Web API is something that you can take and host inside of a Windows service or a console mode application or a WPF desktop application, and you can have clients that call into those applications.